Floorplans are the blueprint of architecture, but most exist as flat raster images, stripping away the structure, geometry, and semantics needed for computational design. Converting them back to precise vector formats has historically been a major bottleneck. Traditional methods rely on fixed query object detection or multi-stage pipelines. They hit a hard ceiling when floorplans get complex, often losing fine-grained semantic details or failing to predict variable-length room boundaries. Raster-to-sec solves this by reformulating raster-to-vector conversion as an autoregressive sequence-to-sequence task. Instead of predicting all structural elements simultaneously, it outputs labeled polygon sequences, predicting one corner at a time conditioned on image features and previously generated points. The technical core rests on two innovations. First, learnable anchors. Rather than directly regressing continuous coordinates, the model predicts residuals relative to these spatial priors. This stabilizes gradient flow and allows the deformable attention mechanism to route focus precisely to informative image regions. Second, token-level semantic supervision. Each corner token carries a semantic probability vector, supervised by a direct cross-entropy loss. This preserves fine-grained room, window, and door labels without the semantic dilution caused by padding in fixed-length sequence models. Paired with a left-to-right generation bias, it naturally handles diverse layouts without a hard query budget. The results are significant. Raster-to-sec achieves state-of-the-art performance on structure 3D, Q/Casa 5K, and raster-to-graph. Unlike baselines that degrade on complex scenes, its performance actually scales with floorplan complexity. It also demonstrates strong zero-shot generalization to real-world, in the wild datasets like WAFFLE. By treating floorplan reconstruction as a sequential generation problem, raster-to-sec bridges the gap between raw raster images and precise, semantically rich vector data. For the full architecture details, training objectives, and ablation studies, check the paper and project page linked below.